Hello everyone, my name is Giselle Kudris and that of my college, Maria Diaz and Aldo Manco. We are from the Industrial Engineering program at the University of Santander, Valledupar campus. From the subject of material science, we are going to explain about crystalline systems and provide networks. In addition to mentioning examples of crystalline solid to understand better.
Okay, the crystalline system. The crystalline systems are defined based on their unit cell with the minimum parallelepiped structure for which the macroscopic crystalline network is built in the three dimensions of space. Crystalline solids that are formed for atom, molecule, or anions that are organized in the regular and repetitive way in the three-dimensional structure. These three-dimensional structures are known as base crystal lattice and are classified according to the type of symmetry they present. Likewise, we can find 7 different crystalline systems in nature, which are cubic, tetragonal, hexagonal, orthorhombic, rhombohedral, monoclinic, and triclinic, and 14 base network are simple cubic, face center cubic, body center cubic, simple tetragonal, body center tetragonal, hexagonal, simple orthorhombic, body center orthorhombic, base center orthorhombic, face center orthorhombic, rhombohedral, simple monocycle, base center monocycle, and tricline.
Trigonal. It is one in which the X, H, and Z axes are equal in length and 2 of 10, X and Y, for 19-degree angles, while the third Z forms a different angle. It's a single crystal lattice known as tetragonal. It has atoms at the corners of array primes with a square base. In this case, each atom is surrounded by 8 neighboring atoms, which are the same distance in 2 directions, X and Y, and at the different distances in the Z directions. Hexagonal. The hexagonal crystal system is one which the X and Y axes are of equal length and form 16-degree angles, which are other, while the Z-axis is perpendicular to 10 and is of different lengths. It's a single crystal lattice known as hexagonal lattice. It is characterized by having atoms in the corners of hexagonal primes. In this case, each atom is surrounded by 12 neighbor atoms at the same distance in 2 directions, X and Y, and by 6 additional neighbor atoms at the face of the prism.
Rhombohedral is the one in which the S, Y, and X axes are of equal length and 4 equal angles, but at no 19 degrees to each other. It has a single crystal lattice, known as rhombohedral. This is very easily recognized by having atoms on the corners of a rhombohedron. In this case, each atom is surrounded by 6 neighboring atoms on the same distance in all directions. Monocyclic. It consists of a binary axis, a plane perpendicular to it, and a center of development. The detonation of the monocyclic network is dot M. A crystalline system is described by 3 vectors. In the monoclinic system, the crystal is described by vectors of different lengths. As is of the Hornbrick system, it forms a rectangular prism with a parallel grain and its base. Therefore, two vectors are perpendicular while the third forms an angle of the 90 degree with the other two.
Well, tricline. A crystallographic system is described by 3 base vectors. In the tricline system, the 3 unit parameters are different from each other as the angle that the crystallographic axis, for which a other into are different from 19 degrees.
Right. Determination of crystalline structures. Crystalline structures can be identified through the application of X-ray diffractions (X-ray techniques. Tests are based on the phenomena that appear when a beam of X-rays of a certain wavelength hit a crystalline structure. In effect, the incident X radiation causes the atoms of the crystal to emit electromagnetic radiation of the same wavelength, which, as soon as certain conditions are met, produces diffractions. The X-ray diffractometer is the instrument that allows the identification of crystalline structures based on Bragg diffractions. Okay, this figure is X-ray diffraction exam.
Example of crystalline solid materials. Ice. Ice AH has a hexagonal structure in which its oxygen atom or a water molecule have 4 other hydrogen atoms and its closest neighbors, located on the vertices of a regular tetrahedron whose center is the oxygen atom or its teref.
Other example is copper. Pure copper as a vibrate lattice, showing a phase center cubic, FCC phase center cubic, a structure in which the trial space are distinguished. In the structure, atoms are located on the vertex of an unit cell and the center of the phase.
Finally is aragonite. As the hot spring water evaporates, the calcium it contains precipitates, and when it comes into contact with air, combines with oxygen and carbon dioxide to form aragonite crystals. Is orthorhombic. Well, that was all. We hope you like. Thank you.